All right, guys. So this is how we're going to go about solving a series circuit. I'm sorry, parallel circuit. We're still going to use Ohm's law, but the rules are slightly different. So in a parallel circuit, the voltage and the voltage drops are going to be the exact same. So if you know the battery, V1, V2, V3 are all the same. The current, though, is going to be different because it's got different paths it can take. To find the total current, you're going to add up all of them. I1, which goes through R1, I2, which goes through R2, and I3, which goes through R3. Now, to find the total resistance, total resistance, sometimes called REQ, that whole thing is very simple. I would say let's go about it first over here. So while we're doing that, we have R1, R2, R3, right? So because we have to take the inverse of these things added together, plus R3. Dot, dot, dot means if we have more, we're going to do more. So we have 50 as our first guy, so I would do 1 over 50 plus 1 over 100 plus 1 over 100. Now, this can be done two ways, right? So if you did this in your calculator, you could do 1 over 50, get this guy, plus 1 over 100, plus 1 divided by 100. And you're going to get this decimal. But it's going to, you'd have to do basically 1 over that answer, right? You got to take the inverse of this. And when you do so, you're going to get 25 as our total resistance. So in our notes, the total resistance is going to be less than the value of any individual resistors. Come on, pause. Or sometimes the easier way can be find the least or the lowest common factor between them. So 50 and 100 would be 100. So if I had to double 50 to get to 100, I would double what's on top. So I'd have 2 over 50. These guys would stay the same. 2 plus 1 would be 4. And you just take the lowest, right? You take that factor of the 100. Sorry, this should be. And so 100 would go on bottom. And then once you get this, you have to flip it. So it would be 100 over 4, and you would get 25. That's your total resistance. So once you have that, again, let's make our tables. You have 1, 2, 3 resistors, so we're going to have 1, 2, 3. Sorry, guys, just had someone come and talk to me. Okay, so back to our parallel. So now that you have the total resistance, right? You have 1, 2, 3 resistors, so you're going to have however many there are plus our total. So we knew the resistor values are, all right, these were our givens. The 50 ohms, the 100 ohms, the 100 ohms, and we're given total voltage. All right, remember that the battery is always total voltage. So things we don't know are the blanks. We did this over here. Either way you can do it, works. So our total resistance, RT, is this 25 ohms. So using Ohm's law, you guys can pretty much, if you have 2 of the 3, you can solve for the other pieces. So again, how it works, you cover up the missing part. So V over R, and you got to use the guys that are in the same row. So total current, IT, would equal VT divided by RT. And that would be, what do we got? We got 12 over 25. So I'm just going to take that and pop it in. 12 over 25. And we're going to get the current, a total current of 0.48 amps. So that is going to be our total. Now in series, we used to say, okay, once you found total current, you could just fill this in because it was the same everywhere because it only had one path. Here there's 3 different paths, so the current's not going to be the same. But one of the rules is the voltage drops across each, all right, is going to be the same voltage that is applied from the battery. So these are all 12, or whatever our battery value would be. And then to find the current going through each of these paths, I1 goes through R1, I2 goes through R3, and then I3 goes through R3. So again, using the triangle, I1 would be V1 over R1. So 12 over 50. And we're going to get 0.24. I2 would be R2, or V2 divided by R2. So 12 over 100. And then I3. V3 over R3. And since R3 happens to be 100 again, we're going to have the same answer as this guy right above it. So like what we had done previously for the series circuit, once you figured out the voltage drops, you had to add them up to make sure they equal out to the current. You can't have more or less current, okay? So you may have to round occasionally. So when you add these guys together, you actually do come out with this 0.48 amps, which is good. So that means these guys are our correct answers, and we can throw them into our table. And that is pretty much, guys, what we're going to wind up doing. Okay. All right.